Okay, so the first part of the lesson was just basically plotting. And here, for example, if I want to plot the sequence of terms 1 over n from n equals 1 to 15, and you can see obviously it decays from 1 to 1/2, 1/3, etc. And notice I don't see the full range here, so what you can do again is you can do a plot range and kind of change it. Don't forget the x-coordinate comes first, so we'll just go from 1 to 15. And then I can tell Mathematica, but the y, I do want to look from 0 to all the way up to 1, because right now it's only looking as high as 0.7. And if you notice, these brackets don't change to black until everything's complete. Sometimes you'll have an error just because you didn't close brackets. So now if I hit that, I can see clearly all the way up to 1, and it doesn't leave that out. Okay, but this actually doesn't help us, because what we're interested in is not just the terms of 1 over n, but what happens if I sum, or if I start adding 1 plus a half, plus a third, plus a fourth, plus a fifth. Okay, so a command that we're going to actually have to go to is the command sum. Again, I'm going to have brackets. So for example, if I want to sum up 1 over n, and I want to go from n, we'll just start from something we can know. From 1 to 2, 1 plus a half is 3/2. Now if I go from 1 to 3, then 1 plus a half plus a third is 11/6. And I can take this as far out as I want to go. So for example, if I want to go up to 30, then you get this kind of messy fraction. If you don't like that messy fraction, you can use a command n and close it in brackets. So you can nest a command within a command, and then it'll give you a decimal approximation, but that's not really what's important here. Okay, so sum will add up the sequence, so in other words, it'll give us a series. So I can actually combine these ideas, because what I want to plot is not the terms, but the sum of the terms. As I add more and more, then I can actually, instead of plotting 1 over n, I can have it plot the sum of 1 over n as you add terms on and on and on. Okay, I'm going to actually get rid of plot range here, because that might throw off my graph. Okay, let's see if there's any issues here. Okay, I want you to notice you graphed a straight line. So what went wrong? Okay, it's the way we set this up, because I'm already saying it's the sum from 1 to 30, but I want to keep it more general. I want to actually go from 1 to n. So I'm going to let n grow from 1 to 15. And you can see that the sum is slowly growing, and whether or not it's convergent or not is not clear. But we can take it further. We can go all the way up to 40, and it seems like it's still growing. It's passing 4 on the y-axis. Let's say if I take it up to 400, and it's passing 5 almost at 6. So it seems like it keeps growing. So if you look at the format of this, let's do another one. So what I want to do is I want to do a discrete plot. But what I want to do is I want to plot a sum. So this is going to get a little bit complicated. I'm going to pick my function. So for example, maybe 1 over n squared. And what I want the Mathematica to do is I want to sum n from 1 to some value n, okay, which will be determined here, as I'm going to let n go from 1 to, for example, 12. Okay, if the n is throwing you off, then you can actually think of it this way. I'm going to go from 1 to k, where k is going from 1 to 12. So I'm going to sum it from 1 to 12. Okay, and you can see it kind of looks like it levels off. If I go out to, let's say, 120, you can see that it actually levels off even more. So we can safely guess, at least just looking at this, that this is a convergent series, because the sum eventually stops growing.